Today's webinar is brought to you by the Vivint Atlanta Chapter and Vivint Mobile Special Interest Group. Today's webinar is hosted and moderated by myself, Melissa Jacobson, PR and Digital Marketing Specialist at Oracy Software and one of the Atlanta Chapter leaders. Our presenter today is Joe Schultz, AVP of Mobile Testing at Oracy Software. Joe is a seasoned developer with more than 25 years of professional application development and QA experience. Currently the AVP for Mobile Testing at Oracy Software, one of the largest and most successful HP BPO sales and services partners. Recognized as an industry thought leader on mobile application development and helps organizations around the globe improve their application quality process. Some housekeeping. Today's live session is intended for all Vivint members. The recording will be posted in the webinar section on Vivint website, visible for all members. Additionally, today's slide deck and webinar recording will be made available to you. We will send you the link via email once they are posted to the Vivint website. If you have questions as we go along, please type them in using the questions pane in the webinar control panel. Here is a picture of the GoToWebinar control panel that usually appears in the upper right-hand corner of your screen. To submit a question, make sure the questions pane is expanded, type in your question, and click on Send. I will now turn it over to Tammy Young, Vivint Director of Special Interest Groups and Chapters. Thanks, Tammy.
Thank you, Melissa. Good afternoon, everyone. I wanted to cover a little bit about HP Discover and some events that are coming up. So Vivint needs your assistance, and what we'd like to do is be the largest group with the most members attending HP Discover. If you haven't been, I highly recommend attendance. I've never had a bad experience, and there's just there's so much to learn and to so much information to be disseminated. It really is an excellent user conference. So here's how you can assist us. We want you to register with the Vivint discount code, which is SWVIVIT, SWVIVIT. And not only will you enjoy a $300 discount, but that will also ensure that you receive Discover information tailored specifically to your needs. There are many, many courses, so I encourage you to use that discount code. And we would like you to pass this along to all your friends that are also Vivint members, and make sure you use that code when registering. So I also wanted to cover some news from HP Software. HP Americas announces the 2014 Awards of Excellence. Nominations are due by March 31st, and winners receive a complimentary Discover Las Vegas attendance and an HP slate, and that is a public presentation, and there's more there as well. Surprises to come. So visit the HP IT Experts community for forums, blogs, upcoming events, and register for that monthly newsletter. Participate also in the upcoming online expert days. And what those are they're hosted by HP R&D and support. This particular one that's coming up is March 25th, and it's on Performance Center, and it's what's new in Performance Center version 12. So make sure you register for that online expert days. Lots of good information. So what I would like to do now is turn it over to Joe Schultz, your AVP Mobile Testing with Oracy.
Well, thanks,
good afternoon,
Tammy.
Joe.
Thanks, Tammy, and good afternoon to everybody that's on the phone today. I appreciate you spending some time with us. Today I'd like to talk a little bit about how to add mobile to your existing HP practice. So I'm, this being a Vivint seminar, I'm kind of assuming that everyone on the phone is an HP customer in some capacity or another. And the fact that you joined this webinar, I'm kind of assuming that you're interested in mobile testing, whether it be for mobile websites or mobile native applications, either one. And the idea, what I'm going to talk about today then, is how to extend that existing practice you already have into the mobile space, to use it to capitalize on all of the tools and techniques and skills that you already currently have in order to address the mobile requirements you have in your environment. Just for a quick second, we have to pay the bills, so I have to give you a quick commercial on Oracy. For those of you that don't know Oracy, we are HP's largest and oldest partner in the software quality space. We've had a relationship with HP since they acquired Mercury, with Mercury literally decades before HP acquired them. So we have a very long-standing history in the HP tools, everything from functional testing to performance testing, security testing. We do sales of the products. We do full complement of services around the products, including implementation and training, as well as telephone support as well. We're one of the few authorized partners of HP that can do telephone support. So anything you need related to HP, feel free to give us a call. We'll be happy to help. What I'm going to focus on is the mobile space today, where we've built a practice around mobile testing specifically to extend the HP tools. So we went out and looked at vendors in the space and tried to pick the best technology we could to complement the existing HP infrastructure. And at the time, this was several years ago, we picked a company called Perfecto Mobile. They were one of the up-and-comers in the market, not the big dog, if you will, but they were one of the products that we thought was best positioned for the future. And then about a year later, HP actually thought the same thing, came to the same conclusion that we did, and signed a relationship with them as well. And so the products that I'm going to talk about today are all underpinned by the Perfecto Mobile technology, which is also known as UFT Mobile. So you're going to hear me say the words UFT Mobile a bunch, and that's kind of synonymous with the Perfecto technology. So if you've heard of Perfecto, you can insert UFT Mobile there as well. Okay, so I don't need to tell you that mobile's big. All you have to do is walk down the street, and you'll see 4 out of 5 people holding a smartphone or a cell phone up to their ear or something. Everyone uses cell phones and mobile devices of all kinds these days, whether it be the phone itself or tablets of various flavor and format. Tablet sales actually have already eclipsed PC sales, which was something that wasn't predicted to happen for a couple more years, but it's already happened. Kind of an interesting fact that I like to share with people is that you may not realize, but there are about 7 billion people on this planet, give or take a few hundred million between friends. And of them, half of them, at least, have a mobile phone. In fact, this statistic says 4 billion, which is about 2/3. And I just saw a statistic recently, just a month ago, that said that number is as much as 6 billion. So 6 billion of 7 billion people in the world use a mobile phone. And the interesting thing is, compare that to some of the other things in the world, like, for example, a toothbrush. Only half of the 7 billion people in the world use a toothbrush, but 6 out of 7 use a mobile phone. So twice as many use a mobile phone as use a toothbrush. That's not only impressive, but it's also kind of scary if you think about it. But that's how big the problem is, right? I mean, we have to think about when we're approaching application quality, we have to assume that every consumer that we can think of has access to our application. And ideally, we want that to happen. We want to put an app out there, and we want to have 6 billion people download it the next day. That would be the perfect world. So that's the kind of the scale of the problem that you have to kind of keep in mind as you're looking at building a testing strategy around it. Now, the problem we have with mobile is that it's a different kind of physical environment. But if you think about it, it's really the same testing that we've been doing forever. So just because it's a new technology doesn't mean that we're going to change our process at all. what we want to do is we want to adapt that process where necessary to support the differences in what the new technology is, in this case, the mobile application. And there are significant differences. So, you know, if you've ever gotten some pop-up error message from an application on an app that you've been running, or you load an app and it disappears all of a sudden, I'm sure none of you have ever had that happen, right? The problem is there are lots of reasons that could have contributed to that particular issue. You know, in a traditional web world, if it fails, 99% of the time, it's our problem. It's because we coded something wrong in the web server or the application code itself. It's very rarely the environmental. You know, occasionally browsers mess up and PC screens GPS and all that kind of stuff. So we do have those kinds of errors, but 90% of the time, the error is in the application. In the mobile world today, that's not so true. We have lots of factors like the hardware itself, the operating systems, which are changing constantly. You know, those of you who might have just downloaded version 7.1 of Apple's iOS just in the last week, you know, that's the next major release, and we just had another one, major release a couple of months ago. 7.1.1 is already on the books, scheduled to come out in the next few weeks. I mean, so the operating systems are changing daily. The form factors on the hardware change as well. We get new screen resolutions and new size phones, new battery capacity, new network speeds as well behind it. So even the network contributes to the issue. Sometimes, in fact, it could be the network provider that's causing the problem. You know, you might have an issue, and it could be because of a timeout that you've hit in the AT&T network or something like that. So there's so many factors that it makes it much more difficult for us as quality professionals to figure out where the root of the problem is. And that's why mobile's difficult. It's not because we have to test stuff we've never tested before in terms of, you know, the process. It's that the technology that supports it is so vastly different, and there's so many more opportunities for things that are outside of our control. So that's the challenge, really, inside of a mobile testing strategy. So how big is that challenge then? Well, here's a quick sample. You know, we mentioned in our description of this webinar we're going to cover a couple of case studies. This is a case study I did for a customer. A customer came to me and said, well, here's what I'd like to test. And I said, how are you going to do that? And they said, well, we're just going to do it manually. You know, we're going to go out and buy some phones, and we're going to have our developers, some of the testers rather, you know, thumb the phones. They're going to plug away with their fingers. And I said, well, have you really stopped to look at that? And so we did a quick calculation for them, for their particular application. They had 9 devices. They had 3 OS versions they wanted to support. They had, in this particular case, right around 900 test cases that they had to support. And so when we did all this calculation, it came out to 8 full-time people just to do one execution of the test plan. One execution across those devices was going to take 8 people full-time for 40 days. I mean, that's just ridiculous, right? It's impractical. They only, in that particular case, the customer only had 4 developers, and they were going to have twice as many QA staff. I don't know very many shops at all. In fact, frankly, I can't name one shop that has twice as many QA people as they do developers. So this is the size of the problem. And if you add to it, then Android variations, you know, for a simple single sprint, you could have to have 50+ people to support manual testing in that environment because of all the variations that we have to deal with. So this is why this is so much more difficult than web testing, because the problem is so much more bigger. It's not that the testing is different. It's just that there are so many more variations that we have to address. Okay, so like I said, it's the same problem that we've been talking about for a long time. I mean, first you got to make sure that the application works the way you expect. That's traditional functional testing. Then we have to make sure it scales, make sure it'll support the demand both on the client side, on the network, and on the back end. And that's traditional performance testing. And then we have to make sure it's safe. So we have to do that to make sure that there's no opportunities, hackers, or malware to attack our environment. So these are the same three questions we've been trying to answer every time since the first application was delivered to a QA professional. What we want to do then is we want to layer our existing tools and technologies on top of that in order to address the problem. So from an HP perspective, these are the tools that we want to look at. In the functional test area, we want to look at things like Quality Center for test management, UFT for test automation. And those are tools you guys are probably already using, in fact. Many of you on the phone are already using UFT automation scripts in order to test your websites or if you have any client-server apps left. What we want to do then is we layer on top of that the technologies we need to support mobile. So UFT Mobile, for example, I mentioned before, is the technology we add to UFT in order to give UFT the hook into physical devices. So these are real physical devices, and I'll explain that in a minute, that we can use then to test our application to make sure it works. We run use cases, just like we would a website, against those devices and run through the whole process. If we want to then also simulate the effect of the network on user experience, we add the Shunra set of functionality, a product that HP just acquired completely a few weeks ago. They're in the process of finalizing the paperwork. Before that, we've been using Shunra for a long time. We've been an HP partner for a long time. And what that lets us do is it lets us add varying network conditions to the environment. So I can actually run the test across a Wi-Fi connection inside of my intranet, but yet I can simulate an exact replica of some remote condition. So I can make my phone sitting on Wi-Fi look like it's actually in an elevator on the 3G network in Chicago. And so I can simulate those kinds of network conditions, and I can vary them accordingly in order to see what the user experience will be. Then I can do all that same stuff under load. So for performance testing, the difference is we use Performance Center, obviously, to create the simulated transactions, and then we'll layer on UFT Mobile to give us real user experience under load. So it's a combination of tools, but again, layering right on top of the same Performance Center tool that you already own. Performance Center includes some extra bundles I'll talk about as well, and frankly, most of you probably already own those and are able to do mobile testing today and don't even realize it. So I'll give you some specifics about that later. And then we add security testing to it as well. We want to make sure that the application's safe. So we need to do both static and dynamic testing, and that's where Fortify comes into play. I'll talk a little bit about Fortify and explain how it touches both the back end and the front end in order to verify points of intrusion, to make sure that you've covered all your bases when it comes to threats and malware and such. And then finally, we want to do some monitoring. So we wrap this whole thing around with some continuous monitors that check the application on a periodic basis, whether that's once an hour, checking to make sure your production environment is running, or it's once a sprint where we're doing more static testing to check the application before we deploy. But in all of those cases, we want to do monitoring on a periodic basis so that we can verify that all the things that we expect are still working. Monitoring is much more important in the mobile world, in fact, because so many things can change. If I connect to an IP jack, if I plug my PC into a Ethernet outlet, there's very little that really changes over time that'll affect my application. Somebody might put a new switch in or change your routing, but we're talking about making minuscule changes in the ping times, for example, to the server. Whereas if I'm walking with my cell phone and I cross towers or I go into a shielded building, the response time can vary very dramatically. And so I need to monitor all of those types of connections to make sure that the physical environment is still up to the standards that I expected when I did my production testing. So that's the way the picture looks. What I'm going to do now is I'm going to drill in real quickly to each one of these three areas in the white boxes, just to give you a little bit of detail about how that works, how specifically you can take the stuff you have today and layer on the extra mobile pieces to do mobile testing. So first, let's take a look at functional testing. Functional testing is where everyone starts. And And the whole idea of functional testing, of course, is to verify that the application works the way you expected. So we often talk about exploratory testing, for example. That's kind of manually popping around an application to look for problems. Or we'll talk about regression testing. People will mention, building a regression harness where I run automated tests against the application to make sure that nothing I added in this version of the application broke previous versions of the application functionality, etc. All of those things are part of functional testing. From a mobile perspective, what we do then is we layer on this UFT mobile product that I talked about. So UFT mobile is essentially a hardware technology that plugs into the software. So what I mean by that is there is literally a rack of devices with phones and tablets that's sitting there and it's available for use. So when I need, as a UFT scripter, let's say I've got UFT on my laptop, if I want to test on a mobile phone, a real mobile phone, all I do is I connect to a service, a mobile cloud, and I can then pull from that cloud a real physical device, and it shows up on my screen. And I'll show you a picture of that in just a second. That device then can be manipulated, and I can run scripts against it, either for manual or automated testing. And all of the results then are recorded right back in the existing HP tools like Quality Center. So if a defect gets thrown out of UFT, we can automatically log that defect in Quality Center. So it's part of the integrated package of HP ALM. And what it lets us do then is use real physical devices. So these are real physical devices that are located all over the world. I mean, I can do location testing if that's important as well. So I can test an iPhone in the US and an iPhone in Europe and an iPhone in Asia to make sure that my application performs as I expect in all 3 continents, for example. I can do basically any kind of testing that I want to do on these phones just as if I was holding them in my hand. So I can press buttons, I can enter text, I can swipe, I can do whatever I'd like to do. And these devices then can either be public shared devices that everybody in the world can get to, or I can have devices that are allocated specifically to me. That's what we call private cloud. And for most people, for pre-production testing, private cloud is the most practical way to go. In a private cloud, I can count on those devices being there consistently. Their availability is consistent, and their experience is consistent as well. So however I left a phone the last time I used it is how it will be there when I start up the next day. Whereas in a public kind of cloud model, you can't count on the format of the phone. The previous user could have wiped apps or changed locales or whatever they might want to do, which would change the experience and it generally makes automation impossible. So private cloud is what most people will use to get started. And we can do that private cloud both as a hosted service or as an on-premise offering. So you can actually set up a cloud inside your intranet, sitting on the tester's desk, if you will, and connect that directly into UFT for functional testing. And all this is real time. I'm not talking about emulators. I'm talking about real physical devices. We do also have emulators that you can hook in, and it's a little cheaper, frankly, to use emulators. So a lot of people will use emulators for the initial testing, but once you get into compatibility and integration systems tests, you really need to run on real physical phones because that emulator is not the same as the physical device that the carrier put out. And as I said, what that does then is it plugs right into UFT. So you guys should recognize this screen, those of you that have used UFT before. On the left-hand side is a UFT script. It's a set of command calls that are accessing the device that's over on the right-hand side. So the right-hand side is that UFT mobile plugin that I talked about. It's the connection between UFT and a physical device that's sitting somewhere in the world. That phone could be in Boston. It could be in Bombay. I mean, it makes no difference to us where that device is located. The point is that the script is accessing that device and it's executing commands against that device as if I had the device in my hand. So it's just an extension of the existing UFT. And UFT can do anything, anything you can do in UFT normally, you can do with UFT Mobile. So I can use data tables, I can use parameters, I can use functions, I can set up reusable actions, I can, use BPT. I can use anything I want to do, anything I would normally do with UFT, I could do against these physical devices. So the whole point is I'm extending my existing practice. Don't throw away the tools you have, don't throw away the process you have, and don't retrain all your people, right? Just leverage your existing skills and add the one little extra piece, which is knowledge of the UFT. Now there are some, specific scripting methods that are specific to the devices themselves. So I don't mean to say that this is magic, but the point is it can coexist. I can actually build a script in UFT that tests a website and repurpose that same script with very minimal changes to test the mobile website as well. In fact, if your applications or websites are consistent across devices, there's very little changing potentially that's necessary. I can also do coordinated tests. So that's something else people ask me a lot. I've had customers, for example, who will write a UFT mobile script that first goes to the website. So UFT accesses the web browser and does an automation script to do something through the website. Let's say you add a new order. Then they go to the mobile device and they check the status of that order and return the total value, let's say, of the order, and then compare that against the value that's in the database. So UFT is accessing websites, it's automating against phones, and it's also accessing databases to do verification. And you can do all of that inside of one UFT script shell. So it literally integrates directly into your existing practice. So here's an example, one of the case studies I promised you. We were working with a large regional bank. They came to us and they said, well, we've been testing manually, and it's getting too unwieldy. They had a whole lot of stuff to test. They wanted to test their website. They wanted to test a native app that they built for both iOS and Android. And they also wanted to test some of the phone integration, things like text banking. They wanted to be able to send a text to get a balance and verify that that balance was correct. And also mobile alerts, so that they were doing push notifications to the mobile device in the case of, let's say, a bounced check. Somebody bounced a check, they send the mobile device an immediate alert to tell you of the problem. So they wanted to test all these kinds of things, and they had been doing it all manually prior to talking to us. They tried a little bit of automation here, there, but there were problems with all of the automation tools that they tried. For example, they had people all over the world. There were testers onshore and offshore, and there were multiple locations. And so the testers couldn't get to the devices if the devices were tethered to the PC. They also had problems with some of the automation tools that couldn't handle scripting across multiple devices, so they'd have to rewrite tests for the Android after they'd written for the iPhone. And then sometimes they'd even have to rewrite tests between a Samsung and a Motorola Android. And so it was those kinds of things that made it very difficult. So they came to us and said, what can we do? How can we fix these kinds of problems to support a global testing? So what we ended up doing with them was going through a rigorous evaluation of tools. We looked at a lot of things and ended up picking UFT Mobile as the tool of choice. This was actually prior to a lot of the standardization. This was several years ago that this happened. And so at that point, the tools weren't as well integrated and as standardized as they even are today. What we ended up doing then was setting up a private cloud with 40 dedicated devices. So they had devices dedicated to them of all of the types that they needed. Those were 40 different kinds of phones with different carriers and different form factors and different versions of operating systems. And in this particular case, we hosted those devices in our office. So we physically put the devices in the Oracy office because we were located right within the customer's geography. They wanted the application to run inside of their bank footprint so that they could do some location testing as well to make sure that like ATM lists came up. So those devices were hosted by us. We took care of all the device management. They then could have people from all over the world access those devices. So they didn't need to buy an iPhone for every tester or even for every office. They only needed one iPhone of a particular type. And then anyone in their bank network could connect to that device and use it in real time. They then built an automation harness in UFT. So we used UFT to build some device-agnostic scripts. We would write one script that tested, for example, a function like a check deposit. And then that script would get repurposed on every one of those 40 devices. It would be reused with very little or no modification necessary at all across all 40 of those devices. And that ran right inside of UFT, so we were using Quality Center to kick off the tests on a scheduled basis. All the results were going back into the Quality Center dashboards, and of course all the defects were being created as they were being identified. All of that happened just like it would if you were testing a website or even older client-server apps. In the first year alone, then, they were able to achieve 60% automation. So they had hoped to get to about 80% automation over 3 years. The first year goal was around 30 or 40%, and they actually got to 60% automation. So 60% of their regression was automated within the first year, which is a phenomenal achievement within 1 year. But that was because we were able to leverage so much of what they had already had. They had experience in UFT, as did Oracy, and we were able to build these scripts pretty quickly and run them across all these different devices. So it was a very cost-effective solution for deploying this functional test. So that's just one example. I mean, I've got a dozen examples like this. This is just one example that had very good results we were very happy with. And, it shows what's possible just by simply adding a few extra components to your existing infrastructure. So let's switch gears a bit and talk about security testing. I mentioned, on that first slide, we wanted to look at functional performance and security testing. So let's talk a little bit about security. Once I write the app and I make sure it works, what I have to do now is make sure that it doesn't have any possibilities for intrusion, that it doesn't have any vulnerabilities that people can take advantage of in order to exploit my network or my application data, either one. Here's a good picture that HP shows a lot. You may have already seen this. I just think it gets right to the heart of the matter. The whole point is I look at this app on my phone and I see opportunities for doing things, right? I see a field where I can put in the username, and I see a field where I can put in my password, and a button I click to remember me, and buttons to generate reports, etc. These are all pieces of functionality. And what we do as QA professionals is we test that functionality. So we test to make sure that the username and password are entered correctly and that they get used the right way by the application, and then I get the positive test case result when I put the right username and password in, and I get a negative test case result when I put in the wrong username and password, etc. So I see this as a functional test. But when a hacker looks at that same application, what they see are opportunities to break your functionality, basically. So they're not worried about whether the username and password actually get verified. What they want to see if they can use SQL injection to try and override the functionality that you had intended in that application. So hackers look at applications very differently than developers do. Developers are trying to get things done. Hackers are trying to break things. And so when we start testing for security, we have to think about it in this model. We have to think about it the way a hacker does, not the way a developer does. So it's a very different mindset. And in fact, in most organizations, security testing is actually a separate group of people within the organization. I don't know how you do it in your organization. Everyone's a little bit different probably. But very often there are specialists within the company, whether they're part of QA or development or a separate operations security team. But there are specialists that focus on security testing. And that security testing then needs to try things that weren't expected and to use kind of commonly known hacking techniques in order to see if we can break the application. Things, like I said, like SQL injection or an IDS error or memory overflow leak that causes a corruption in memory that I can exploit. Things like that. There are, you've read, I'm sure, dozens of examples in the newspapers of how hackers have gotten into applications by using one of these pretty well-known techniques. And it's because the developers don't think to test for this, and the QA organization doesn't have the tools typically to test for this. And so we have problems like these in our applications every day. So that's where automated tools come into play. And some of you might already be using the Fortify tools for testing. Fortify is HP's product for security testing. What Fortify does is it tries to reproduce those kinds of hacker errors or hacker situations to break the application. It tries, for example, SQL injection to see if it can inject direct SQL into a text field that the application will then execute unknowingly. So there are those kinds of things built in. I believe last I saw there was something like 110 different types of hacker attempts that Fortify can reproduce or simulate. And it's been doing this for a long time on web-based kind of applications and even the client-server type applications. But in the mobile world, there's a new product called Product for Fortify Mobile that will do the same thing for the mobile applications. And that can take the form of both static testing. And static testing is checking the code of the application itself, basically running codes through scanners to look for things like memory overflows and data leakage and things like that. Or it can be dynamic testing, which is actually trying some of these things against the application, actually injecting some SQL to see if it returns a result that wasn't expected, a result that creates a vulnerability in the application. So we can do both static and dynamic testing on all of these different application types. And so for mobile, that's going to check all three tiers of the picture I showed you a minute ago. It's going to check that client side to check the operating system itself, the iOS or Android operating system. It's going to check the network to see if there's vulnerabilities in somewhere in the AT&T or Verizon transmission, for example. And it's going to check your back-end server like you would for any application to make sure that your servers are responding appropriately to those kinds of requests. So it's a true hybrid analysis of the entire environment from source code all the way through deployable application and using both static and dynamic tiers. And again, it's for those of you that are Fortify users already, it's just additional protocol, it's just additional functionality that drops right into your Fortify environment. For those of you that aren't, it's an easy extension of your existing HP environment, and it talks directly to Quality Center, for example, to kick off tests, and works with all the other products as well. So that's the Fortify product line. A little different than UFT Mobile I mentioned, but that's because of the nature of security testing. And then finally, the third category I talked about was performance testing. Performance testing is checking scale of the application to make sure that it runs appropriately. We ideally, right? I mentioned there were 6 billion people that have access to cell phone. Ideally, we want 6 billion downloads. It's the day after we deploy the application to the iTunes store. But of course, the first question that comes to mind is, well, can I handle 6 billion downloads? Will I be able to handle 6 billion people using my application? So I have to test for that, and I have to test based upon my expected scale. I had one customer that when we first started talking to them, they were just about to launch their application. And they told us that they had hoped to get 1 million downloads of their application within the first 12 months. So they were building their architecture to support that assumption that they were going to get 1 million downloads for the next 12 months. They reached 1 million downloads in 5 weeks. So within 5 weeks, they already had as many users as they had expected to have within the first year. So that's a great problem to have, right? I mean, you want that problem. You want to have, hit your target in a 12th of the time or an 11th of the time that you would expect it to happen. But the question you have to ask yourself then is, well, can I handle that? Will my back-end systems be able to handle that? Will my network connectivity be able to handle that? You know, does my ISP contract have enough capacity to support that kind of bandwidth? Those are the kind of things you have to make sure you have in place, and you have to test for those on a periodic basis as well. So that's where the performance testing comes in. In a mobile world, then, there are a lot more traditional characteristics that I have to look at than there are in a web app. So I have to look at not only the network speed and latency, which I would do in a normal test, you know, doing a ping, for example, against the back-end server from your client, and then create a load as well. So I look at latency and I look at load by ramping up a number of virtual users with Performance Center. You know, that's how I would normally do a test. In the mobile world, though, I have to add in, for example, all the characteristics of the mobile environment. So I have to worry about how fast is iOS, and I want to compare, for example, iOS 6 versus iOS 7. Is iOS 7 faster or slower for my application based upon the functionality that I'm executing? And then that may vary, of course, across different kinds of handsets. I mean, an iPhone 4 is significantly slower than an iPhone 5. So I can execute the same test, and the user experience will be significantly different. The performance of the user experiences will be significantly different on that newer handset because it's much faster. That affects then how much latency I can afford to have in my transaction. You know, if the phone is responding faster, then I can take a little bit longer on the back end, and the user doesn't mind. It still meets his criteria for how fast the response is. But I have to keep that in mind. I have to keep in mind the operating system and the handset, and then even most importantly probably, the network itself. You know, if the user's on a 4G LTE connection and they're standing, you know, 5 feet away from the cell phone tower, they might have fantastic throughput, you know, approaching Wi-Fi kind of speeds, and the performance would be one kind of profile. Whereas if they're, you know, inside of a hospital, sitting in a waiting room, checking their email while they're waiting for the doctor, the shielding in the hospital could interfere with the network and either cause me to completely lose my signal, or at best, it would cause me to degrade my signal such that I'm going to get really poor response. So those things all affect the transaction, and frankly, they all become your problem. You know, whether the user is sitting 5 feet from the tower or in that doctor's waiting room, you have to worry about, because you're going to get the defect report when they report a failure. They're going to say, oh, that stupid app, when in fact it's really a performance characteristic of the network. Now, we can't solve every problem. You know, if I'm in an elevator and I've got no signal whatsoever, well, there's nothing the application provider can do to fix that problem. But we do have to kind of test for the 80-20 rule, right? We got to test for what's our most likely scenario, what will 80% of our customers experience, and then build the environment to support that. So you do have to test for a lot more conditions in the mobile world because of all these factors. And that's where Performance Center comes in. You know, I mentioned early on, we drop Performance Center right into our mobile testing strategy, just like we would for a traditional web app. I use Performance Center to build the virtual users, which are going to simulate transactions against my back-end server. But keep in mind that Performance Center is creating a synthetic transaction that doesn't really run on hardware. So if I wanted to simulate 1,000 users, I'll simulate, let's say, you know, 995 of them through Performance Center, and create those as mobile transactions using the mobile protocols that are built right into Performance Center. And as I said at the beginning of the call, many of you who are Performance Center or LoadRunner users already own the protocols you need. There are mobile true client and traditional rich internet application protocols that you can use to build these transactions, and it's all part of the Web 2.0 bundle, so many of you already own those protocols. But that doesn't test the real user experience on the phone. That loads up the server and simulates the server response, but I'm not simulating or really getting much information about the end user environment, the actual phone, or the network. So that's where we layer in then UFT Mobile and Shunra. UFT Mobile is using those same phones that I talked about earlier for functional testing. I might use 5 of those to run tests while Performance Center is loading up the server with its 995 transactions. I'll do the other 5 on real physical phones, and I actually use, VGen, for example, to launch these scripts on the mobile phone. The mobile phone then gets the real user experience that includes both the operating systems and the device characteristics as well as the network effect of the transaction while the servers are under load. So I'm getting both server statistics from Performance Center and end user statistics, real user experience off of the UFT mobile devices themselves. So I get real user experience under load. Now I could do that by running a whole bunch of UFT mobile devices in a variety of places, but I can also use a smaller set of UFT mobile devices and simulate different network conditions using the Shunra technology. So for example, I can use Shunra to say, let's create a profile that simulates a 3G connection in Dallas, Texas. And so what I could do then is have that UFT mobile device, a real iPhone, running in the rack somewhere, either on your desk or in a hosted data center. And then it connects to Shunra, which gives that transaction the network characteristics of a 3G connection in Dallas, for example. And then the user experience I'm going to get on that phone would be just as if that iPhone were sitting in Dallas running on a 3G network. So rather than having to go run and place a phone in Dallas and find a 3G network, I can use Shunra to simulate those network conditions. And I can use that one device, that one iPhone, for example, I can buy one UFT mobile iPhone. And I can use 11 different Shunra profiles to simulate 11 different network conditions, different locations, network types, network speeds, latency, network quality rates, things like jitter or packet loss. I can vary all those characteristics and get different conditions under which I test using just one device. So it's a great way to get both real user experience out of UFT Mobile, but then vary that experience by network condition without having to go buy a dozen of those phones or 10 dozen or whatever it might be. So it's a combination of, again, just like we talked about before, tools you have, Performance Center with the protocols you probably already own, and mixing and matching then UFT Mobile and Shunra on top of that in order to do the full function, full feature kind of mobile testing. As I mentioned, these are the protocols that you'd use inside of Performance Center to make this happen. So there's a mobile truth client, which is what you use for browser-based applications. When I want to use, I want to simulate a transaction coming from a mobile browser, a mobile website, then I use the mobile truth client. If I want to simulate a native application, then I use one of the mobile app protocols to simulate what would be a normal mobile app calling a web service to my backend. So I've got a couple of different protocols here. And these are built in. I believe they started with LoadRunner 10, and they were definitely in LoadRunner 11, and of course they're in LoadRunner 12 coming out soon, in fact with some improvement. So these are protocols that you may very well already own, and you can start using today to get simulated transactions, synthetic transactions for mobile. And so here's a case study. You guys may have seen this before in various presentations. This is a study that we did with a customer one time where we wanted to show the differences in mobile. So we ran a test for 500 users, and you can see the graph that came out of Performance Center. This is an actual graph from Performance Center on the screen. And it shows that really performance was stable across the entire 500 user set. So we ramped it up over time. And then, we're simulating 500 users, pumping it out to the server, and the server thought was responding just fine. So the customer had estimated, yeah, we can support over 500 users. But then we said, well, wait a minute, let's do some real tests with real mobile devices and using the mobile protocols instead. And the results look very different. In this case, we were applying the Shunra technologies. And what we saw was that the real capacity was actually less than 200 users. So we thought we were golden to 500, and instead it was less than 200. And that's because the network profiles, if you will, the usage profiles for a mobile transaction are significantly different than for a web-based kind of application. Mobile applications tend, for example, to hold resources in memory far longer than a PC application would. That's because of the latency in the transaction. My server, your back-end server, has to hold data a lot longer because it might lose these connections to the mobile devices, so it has to cache that information, and it has to hold memory pointers, and it has to keep sessions open, things like that far longer than it would in a PC-type application where I get a consistent ping from the PC and I know whether that browser is still connected or not. So this is an example, a live example where just by changing the client endpoint, so it's still a mobile website, but it's still a website, but it's being run on a mobile device versus being on a PC, just changing that one thing, meaning the browser that the client was using, dramatically changed the performance profile of the application, of the back-end server in this case. So, these kinds of things, I again, have many examples of these. But the point is you have to mix and match real mobile tests in your process, in your performance test, in order to verify that your infrastructure can support mobile users versus PC users. And you'd want to estimate then, based upon your experience or based upon your user base, how many of those would be mobile and how many would be PC-based, and build a mixture in Performance Center that mirrors your expectation of production usage, whatever that might be. All right, so you've been listening to me babble now for 45 minutes or so. I've covered 3 areas primarily. I've covered functional testing, performance testing, and security testing all around mobile. And what I tried to do was give you a flavor for how you could use the stuff you have today, the tools you already have today, and just add a little bit extra in order to be able to use those same techniques and processes for mobile testing. What I'm going to do now, we don't have a whole lot of time, but I'll try and take a couple of questions here. So I'm going to look at the chat logs and see if I can grab a question out of there that might have come. Okay, so here's a question I can answer real quickly. The question is, when we talk about UFT Mobile, are we talking about emulators or real devices? Well, the answer to that is pretty simple. It's real devices. We can do emulators. We can mix and match. But realistically, more than about 60 to 70% of QA testing has to be done on real devices. You can't get a good integration test or compatibility test without doing that. There's also a lot of new use cases, for example, in mobile testing, like checking screen resolutions. If I reorient the phone, if I change it from portrait to landscape, I turn it, from up and down to right to left. When I move the phone, the screen rotates, and now everything rescales. And I want to make sure that when I go back and forth, that fields don't get cut off, text isn't running off the screen, buttons sometimes overlap when they rescale. So you want to make sure that all those visual elements work as well. So all of those kinds of things have to be run on real devices. So UFT Mobile is real devices. It's an environment where I'm running against a real physical phone that's sitting in a rack. Here's another question. It says something about, it asks about concurrent tests. So I think the intent of the question is, can I use multiple users on a device at the same time? How is that possible? And the answer is it's not possible. When I talk about using a real device, it's just like holding a phone in your hand. So if I'm manipulating the buttons on that phone, if I'm pushing buttons and running an app, no one else can use that phone. So when I say these devices are shared, what I mean is that anyone can use them, but they can use them one at a time. It's a serial kind of process. So I might use the iPhone for 5 minutes to run my test. Then when I disconnect, someone else in my organization can connect in. So we're not simulating the phone operating system. You know, we're not. It's not like remote desktop where we're opening multiple shells. Phones don't support that today. There's no way to do that with a mobile phone, not for the in the current technology. So instead, what I'm talking about is sharing those devices across people, one after the other. So you might have to buy. That's a good point, actually. I didn't bring up. You might have to buy 2 or 3 iPhones. You know, if you have 30 people that want to all use an iPhone for testing, you might have to buy 2 or 3 or 4, right, so that you have enough to support your concurrent needs. But the point is, you won't have to buy 20. You only have to buy 4. So you significantly reduce your cost and increase reusability by using these devices in that cloud kind of model. Okay, and then the last question was about the cloud itself. Does it have to be hosted when we hear about cloud? They said when we hear about cloud, we expect that means it's hosted externally. And the cloud can be hosted externally. So, you know, when UFT Mobile first started, it only supported remote clouds, meaning that they were devices that were hosted in the production data center somewhere else. But now there are also UFT Mobile options for on-site clouds, what I often call internal cloud, which means that I can actually take the hardware, I can buy the hardware from HP to sit on my desk, and I can plug phones into that piece of hardware. And I've created, it includes a web server as well. And so I've created an internal cloud that's all behind my firewall, and anyone in the organization can get to it. So it might be sitting on my desk, but people from other offices within my company can still connect into it right through the corporate intranet. So it's a great way to build clouds both in and external to your organization. And you can mix and match, by the way, too. We can build a cloud that has some devices that are local and some devices that are hosted. We can build a cloud extension, it's often called, in order to support, for example, some test cases where I might need to use the phone in my hand. So I want to have some phones that are local to the testers where they can walk over and pick it up and run a test. Then when they're not using it, they can plug it right back into the cradle and anyone else in the world can use it. And then there are some devices I may never need to do that with, and so I can put those in a hosted center and not have the testers to have to ever worry about it. It's all managed remotely and somebody else takes care of that. So we can mix and match all of those things in order to make it work. Okay, I'm out of time for questions here. We're just about at the top of our hour. So I'm going to leave this slide on here for a second, and you can write down the email address. If you have any additional questions, feel free to email me at mobiletesting@oracy.com, and then I'll be happy to answer any others. And so at this time, I'm going to turn it back over to Melissa. Melissa, you still there?
I'm here. Thank you, Joe. That was an awesome presentation. And thank you to our audience for attending today's webinar. Please be sure to complete the short survey after the webinar ends and opt in to receive more information from Oracy and be entered into a drawing for an HP Slate 7. You must be an Atlanta chapter member to be entered into the drawing. Just a reminder that the webinar recording and slide deck will be posted to the Vivit website. In the next few days, you will receive an email with those links. Thanks again, and have a great day, everyone.
The organizer has